Okay, welcome back, class. Today we are going to discuss formal charge and how we are able to use that to determine which structure or Lewis structure is the most stable form of a molecule. If I could sum this video up into one objective sentence, I would say that our objective for today is that we would be able to calculate the formal charge for each atom within a molecule. In saying that, let's jump into the video. The first thing we're going to talk about with formal charge is what exactly is it? Formal charge is a fictional charge assigned to each atom with a Lewis structure, which allows us to distinguish amongst competing Lewis structures or competing skeletal structures. The formal charge allows us to determine which resonance form of a Lewis dot structure is the most stable, or even what configuration of atoms would create the most stable compounds. The formal charge of an atom in a structure is the charge it would have if all the bonding electrons were shared equally between bound atoms. To simplify this, the formal charge is the calculated charge of an atom if we completely ignore the pull of electronegativity. We calculate the formal charge of any atom as the difference between the number of valence electrons in the atom and the number of electrons it quote-unquote owns in its structure. An atom can be thought of as owning all non-bonding electrons around the individual atom and half of the bonding electrons around it. So the formula for an atom's formal charge is the number of valence electrons minus, in parentheses, the number of non-bonding electrons plus half the number of bonding electrons, in parentheses. Let's talk about the compound of hydrogen cyanide, or HCN. If we do the Lewis structure for these molecules, then we could have two possible structures as so. How do we know whether this molecule is a carbon central molecule or a nitrogen central molecule? We can figure out which compound is more stable or the most stable by calculating the formal charge of each element within the compound. Okay, so let's start off with the nitrogen-centered version of hydrogen cyanide. In this version, we see hydrogen is single bound to a nitrogen atom, and the carbon has a triple bond to the nitrogen atom. We also see that our carbon has a lone pair of electrons attached to it. Let's start off by doing the formal charge of hydrogen. We know that hydrogen has one valence electron. It also has 0 non-binding electrons left over. There are 2 electrons involved in a single bond, so that gives us the formal charge or formula of 1 minus parentheses 0 plus 1/2 times 2 in parentheses. We do this and it equals 0. Now let's move to our nitrogen atom. Nitrogen has 5 valence electrons. All 5 valence electrons are involved in bonding, so it has 0 non-bonding electrons. If we take all the electrons involved in each bond of the nitrogen, it has 8 electrons involved in bonding, 2 for each bond. So the formal charge is 5 minus parentheses 0 plus 1/2 times 8 in parentheses. This gives us positive 1. Finally, for this molecule, we can do a carbon atom. For our carbon atom, there are 4 valence electrons, and it has 2 non-bonding electrons in this configuration. This gives us a total of 6 electrons involved in the triple bond. This leaves us with a formal charge formula of 4 minus parentheses 2 plus 1/2 times 6, which equals a formal charge of -1. Okay, so that's the nitrogen-centered molecule. Let's move to the carbon-centered molecule. Okay, in our carbon-centered molecule, we have a carbon atom with a single bond to a hydrogen and triple bond to a nitrogen with no lone electrons on the carbon, but the nitrogen has some lone electrons. Just like in our nitrogen-centered molecule, our hydrogen has 1 valence electron, 2 electrons involved in the bonding, giving us a formal charge formula of 1 minus parentheses 0 plus 1/2 times 2 in parentheses, which equals 0. Now we move to our carbon. Our carbon atom has 4 valence electrons and 8 electrons involved in bonding, so that gives us a formal charge of 4 minus 0 plus 1/2 times 8, which also equals 0. Finally, our nitrogen atom has 5 valence electrons, 2 lone pairs, and 6 electrons involved in bonding. This gives us a formal charge of 5 minus parentheses 2 plus 1/2 times 6, which will also equal 0. Now that we have worked out the formal charge for each possible molecule, how then do we know which structure is correct? Well, here are some basic rules to distinguish the stability between opposing Lewis structure. The sum of all the formal charges in a neutral molecule must equal 0. So if it doesn't equal 0 overall, so we do a formal charge for each individual element, if it doesn't equal 0 total, then that's going to be less favorable than one that equals 0 overall. Okay, number 2, the sum of all the formal charges of an ion must equal the charge of that ion. Let's just say our ion is a -1 overall, then that means once we do our formula charge for everything, we must have a -1 overall for it to be stable. Step 3, or Rule 3. Small or 0 formal charges on individual atoms are better than large ones. So let's say we have multiple structures that have the same formal charges. The one that has the smaller change in charges or the most zeros is going to be more stable than if we have extreme changes in charges. And then 4, when formal charges cannot be avoided, negative formal charges should reside over the most electron negative atom. So if we have to have a negative charge and all these other steps 1 through 3 are fulfilled, then to know the stability is that the element that's the most electronegative has to have the negative charge over it, or the most negative charge over it. So now let's look back at both our hydrogen cyanide molecules. We can see that the sum of all the formal charges of all the atoms in the carbon-central molecule is 0, while the nitrogen-central molecule is also 0. Since both these molecules both have a formal charge of 0, we will have to go to our third rule and compare the size of the individual charges for each atom. We see that the smaller charges win out, so our carbon-centered molecule or carbon-centered structure has a formal charge of 0 on each atom. So that's going to win over our nitrogen-centered molecule, which had a +1 charge and a -1 charge left over to cancel out. That means our carbon-centered molecule is our most stable and abundantly found. Okay, so that's all I'm going through as far as it comes to formal charges and molecules. Remember, this allows us to determine the stability of structures and the likelihood that one will form or one compound is going to occur over another. In saying that, keep up the good work and see you next time.